Imagine looking toward the nearest star system beyond our Sun and discovering a planet that might have conditions capable of supporting life. That world is Proxima b, a fascinating exoplanet orbiting Proxima Centauri, the closest known star to our solar system. But there is an important mystery. Despite its proximity in cosmic terms, Proxima b is incredibly difficult to observe directly. The planet is buried in the overwhelming glare of its host star, making detailed photographs of its surface far beyond what current telescopes can produce. So what can scientists actually learn about it? Quite a lot. Proxima b was discovered through the gravitational influence it produces on Proxima Centauri. As the planet orbits its star, its gravity causes the star to move slightly back and forth. Astronomers can detect this tiny motion by carefully analyzing changes in the star's light. These measurements revealed that Proxima b is a roughly Earth-mass planet located within the star's habitable zone. That sounds extraordinary. But the phrase, habitable zone, does not mean scientists have discovered an Earth-like paradise. It simply means that, under certain atmospheric conditions, temperatures could potentially allow liquid water to exist on the surface. And that distinction is crucial. Proxima Centauri is a red dwarf, much smaller and cooler than our Sun. But red dwarfs can also be extremely active, producing powerful stellar flares and bursts of radiation. For Proxima b, this creates a major question. Could an atmosphere survive under such conditions? If the planet has a substantial atmosphere and perhaps a protective magnetic field, it might be better shielded from its star's activity. But if its atmosphere has been stripped away over time, the surface could be much less friendly to life. Scientists simply do not know yet. This is where the James Webb Space Telescope becomes especially important. Webb was not designed to produce a detailed Earth-like photograph of Proxima b. Instead, its extraordinary infrared sensitivity allows astronomers to study distant environments and investigate the atmospheres of suitable exoplanets through techniques such as spectroscopy. The challenge with Proxima b is its star. Proxima Centauri is enormously brighter than the planet beside it from our perspective. Separating the faint planetary signal from the powerful stellar light is incredibly difficult. Nevertheless, every observation improves our understanding of what is possible. Researchers can investigate the system's environment, stellar activity, planetary properties, and potential atmospheric signatures. And the implications go far beyond one planet. Proxima b is only about 4.2 light-years away. That makes it one of the most interesting targets for future studies of nearby planetary systems. If astronomers eventually determine that it possesses an atmosphere, that would be a major breakthrough. If they discover atmospheric chemistry that could be associated with biological processes, the excitement would be even greater. But even then, scientists would need extraordinary evidence before claiming life. For now, Proxima b remains a tantalizing possibility rather than a confirmed second Earth. And perhaps that is what makes it so fascinating. We are studying a planet orbiting another star while knowing that its light and signals have traveled across interstellar space before reaching our instruments. The planet is real. Its orbit is real. Its potential is real. But the details of its surface remain hidden. And that unanswered mystery leads to an even bigger question. What will the next generation of telescopes discover when they finally become capable of studying nearby Earth-sized worlds in greater detail? The answer could transform our understanding of where life might exist in the universe. The most fascinating question surrounding Proxima b is not simply what the planet looks like. It is whether the world could possibly be suitable for life. At first glance, its location seems promising. Proxima b orbits within the habitable zone of Proxima Centauri, meaning the distance from its star is potentially compatible with temperatures that could allow liquid water. But habitability is much more complicated than distance. A planet needs more than the right amount of stellar energy. Its atmosphere, chemistry, geological activity, radiation environment, and long-term climate stability could all determine whether life has any chance of surviving. Proxima Centauri creates an especially challenging environment. Red dwarf stars are extremely common throughout the galaxy, but many are magnetically active. Their flares can release powerful bursts of energy that bombard nearby planets. Because Proxima b is so close to its star, scientists have to consider whether repeated stellar activity could erode its atmosphere. There is another fascinating possibility. Proxima b may be tidally locked, meaning one side of the planet could permanently face its star while the opposite side remains in darkness. That sounds hostile. But climate models suggest that if the planet possesses a suitable atmosphere, winds could potentially transport heat from the illuminated side toward the dark side. Instead of a world divided between endless day and endless night with no transition, its climate could be much more complicated. There could even be regions where conditions are more moderate. But again, these are possibilities from models, not observations of Proxima b's actual surface. This is why future observations matter so much. Scientists want to determine whether the planet has an atmosphere and, if so, what that atmosphere contains. Molecules such as water vapor, carbon dioxide, methane, oxygen, and ozone can leave distinctive signatures in starlight or planetary light. But interpreting these chemicals is extremely difficult. A molecule associated with life on Earth does not automatically prove life exists somewhere else. Non-biological processes can sometimes create similar chemical signatures. Any future discovery would therefore require multiple lines of evidence. And this is where Proxima b becomes part of a much larger scientific revolution. Astronomers have already discovered thousands of exoplanets. Many are enormous gas giants. Others are small rocky worlds. Some orbit their stars at distances that could potentially allow liquid water. But discovering an exoplanet is only the beginning. The next challenge is characterization. Scientists want to know what these worlds are made of, how their climates work, and whether any possess environments that could support biology. Proxima b is especially important because its host star is our closest neighboring star. At approximately 4.24 light-years away, it represents one of humanity's nearest opportunities to study a potentially habitable planet beyond the solar system. And one day, humanity may attempt something even more ambitious. Interstellar probes could theoretically travel toward nearby star systems. Concepts such as laser-driven light sails have been proposed as possible approaches for reaching neighboring stars within a human lifetime. We are nowhere near sending people to Proxima b, but robotic exploration may eventually become possible. Before that happens, astronomers need to understand the system as thoroughly as possible. Every observation helps. Every spectrum provides another clue. Every improvement in telescope technology brings distant worlds slightly closer to scientific reach. So, has humanity photographed Proxima b's oceans? No confirmed observation has shown that. Have we discovered cities, vegetation, or extraterrestrial life there? No, but something equally important has happened. We have identified a nearby rocky world in a potentially interesting location and developed the technology to begin asking increasingly sophisticated questions about planets beyond our Sun. That may be the real beginning of the story. Proxima b is not yet another Earth. It is a mystery. And sometimes, the greatest discoveries begin with a mystery we cannot yet solve.